Hello, and welcome to my bench. If this is your first time here, my name is Dave. I fix electronics mostly for radio stations and or TV stations and stuff, and a little bit of ham gear. And if you're returning, thank you. Welcome back. Today we've got a different piece of equipment than we've had before. This is a Shure IntelliMix. These are used all over the place. They're the update to the 267, I believe. Actual model number on this is an FP-410. So you can see from the front here, it's got 4 inputs, 1 master output, a battery test switch, a manual auto switch for gain, limiter. It has a peak limiter in it. You've got a peak and VU meter switch, and you've got a headsets, both 1/4 inch and what is that? I forget. Anyway, it's not the little one. 3mm, 4mm, I don't know. Anyway, the little one, the normal little one, and you can pull this out for monitor, which I don't even really know what that means, and I've never used it. But anyway, and here's the on-off switch. As you can see, it comes up a little bit. There's something there. On the back, we have your 4 inputs. They're all mics, mic jacks, XLRs, and each one of them can be either line or mic level in. You've got phantom power here for your mic. I don't know if that covers all 4 of them or not. I really don't know. And you've got in and out for links. Now this means that you can link up several of these on top of each other, and they will. You can use them individually. Like 8 or 12 or whatever. I don't know what the limit is, but you can link them up if you want to for more of them. These are your 2 outputs over here. And they are mic or line level adjustable, either one. AC input here, and here is a tape out for recording, and this is your monitor in for that monitor switch on the front. Like I said, I've never used that. I don't think. Maybe in a remote someplace, but I don't remember. Anyhow, also this will run on batteries. Here's a little battery compartment here. It just slides in here like that, and 2 9-volts. Ta-da, right there. 2 9-volt batteries. Keyed, so you can't get them in backwards. And it has a dip switch inside of it where you can set things like the plus 4, plus 8 for the VU meter. Limit threshold all the way from 0 dB to plus 16. And it's got a built-in attenuator, 13 dB, and infinity? What does that mean? Off attenuator. Oh, okay. So, I don't know exactly. Maybe we'll look that up. It's got last mic lock on. Don't know. And a phantom power switch between 14 and 48 volts. Some of you may or may not know that your phantom power does not have to be 48 volts. I mean, on a regular old computer, you can stick in a phantom powered condenser microphone for phantom power that, and it'll do it just fine, and that's 5 volts. The 48 volts is left over from the old days in telephones where the ring voltage was 48 volts, so it was always there, and you had it, and you could use it for that. But I've run some microphones down to like 5 volts or less, and they still work. It's the presence of voltage that those microphones need, not the current or the voltage itself, just the presence of voltage to make them actuate. So they draw almost no current at all. They're almost nothing. Anyhow, there we go for the look over on this thing. The complaint on this one is one of the channels is lower than the other. And I think you said channel 3. So let's take a look at it. Let's bring up the scope. There's the scope. I've got an input of 1 kilohertz at 2 volts. So put all of these guys on 3. These are pretty good gain on them. So let's see what the scope says. Here's channel 1. Got it turned on first. Okay. Ooh, that's a tad bit high. That's that on 500 millivolts. Let's take that down to a volt. Okay. So there's what we got. 1 volt output on channel 1. Changing fine. It's on 3. Let's go to channel 2. Yeah, it's fine. Let's go to channel 3. Yeah, that is lower. I can get it to go up there, but not on 3. The front is saying, on the meter here, it's saying -4. Let's see what it says compared to channel 2. Yeah, channel 2 is saying +4. So it's saying that it's 8 dB down or better. Interesting. And that's on peaks. VU, +1 VU, and on on channel 3, -20 or -10 VU. So, okay. All right. Well, and it has nothing to do with the auto manual or the peak limiter. I think the peak limiter will come in if we put it up on channel 3 too. And it's on peak. Put it on peak. There's my peak. And crank it up. Yeah, see the peak limiter works pretty well. Let's take the scope up to 2 volts here and crank it up until, oh, the pots are dirty too. Okay, and that's where the peak limiter peaks. I mean, it stops dead right there at the square. So, yep, that works. All right, so channel 3 is very low, and channel 4 just fine. Yeah, channel 4 is just fine. Peak works there too. All right, and I'm doing these all line in. So, yes, we have a problem with channel 3. Okay, well, let us take it apart. Turn it off. Turn it off. No, it doesn't look. There's not too much to take in these. Cover off these things. I think it's just 4 screws. 4 long screws. Holy smoke. Okay. I've worked on a few of these, but usually they get treated pretty roughly, and it's mechanically broken stuff, like XLR connectors being worn out. Somebody broke a switch because they dropped it. You know, they use these in studios, and they take them out on site when they're doing remotes and stuff. So they get treated fairly roughly. They're nicely built. Got little fingers in here to cut down on RF. Remember, you might be using this in a close-in RF situation. Okay, well, that's the inside. That's what the inside of one of these looks like. Let's see. Can we do this closer? Yeah, here we go. Yeah. So what you got over here is you got power input, audio outputs, and audio inputs back here. Here you got your little matching transformers. Yes, Shure still likes transformers, and I'm old-fashioned, so do I. Power transformer here, not very big, doesn't take much. And this is a power converter. It takes 1 voltage from here, separates it out, and makes 3 or 4 voltages coming out, including, I think it even puts 45 volts out for the phantom power. This board is the Magic Sauce board. This is the thing that makes this thing an IntelliMix, and the ability to stack them up and control them. This is your the board for your LEDs on the front. I don't think, no, the pots are not on there. Anyhow, that's what the inside looks like. And this is your audio output transformer. Transformer in, transformer out, the way it should be. All right, well, that's interesting. Let's take a look at this thing and see what we got. I mean, first of all, we're going to do voltages, although I'm sure the voltages are right because, hey, it works on 4 channels, but just because it's a rule. Now, if I remember correctly, these things, they don't actually have a good, the case or the cabinet is not ground. I believe, if I'm not mistaken, that the end of this capacitor in here, that's the part of the power supply, I believe it's ground. So we'll hook it up to that, and there's the meter. It is on. Let's get a manual up here. Let's go back to here. Turn the meter on and turn on the manual. Ooh, I think that needs to be shrunk down a little bit. Yeah, where are you? Whoops, manual. Unlock that. Yeah, kind of big. All right, there we go. I don't know if you're going to actually be able to see all of this, but anyway, I got to be able to see it though. Let's see. The manual, power supply. Let's see, where's the power supply schematic? Ah, here it is. All right, so according to this, we've got what? Minus V and plus V. So this is going, what, going to be ground? Yeah. 24.3 volts. All right, didn't blow up anything. Let's see, the next one over should be 48 volts, or approximately 49.2. That's okay. And the next one should be plus 15, 14.96. That's fine. The next one is minus 15.0. That's good. This is ground. This next one should be 4 volts plus and 4 volts minus. All right, so all the voltages are good. All the voltages are good. So what does that mean? Well, we got to get under here to get to this stuff, so we sort of got to take it apart. We're just going to trace this thing down. Audio wise, and see if we can see where it stops. Alright, well, there's that board. Something to set it on so it doesn't short out. Something smallish. There we go. Alright, perfect. Alright, so here's our input amplifiers. We've got to take this guy off too. Like I said, I've worked on these a couple of times. I am by no means the master mechanic, but I do sort of remember where everything is. Alright, so there's you. Take you out. Just lean you back here. You're good. Alright, so we've got our inputs here and our switching and output over here. And I think there's another one under there you can't get to, but we'll see. All right, so let's go for the inputs first. I need a scope probe. Okay. and ground, I think. Yeah, ground is on the center of these guys, of the XLRs. Okay. Let's go back on the manual to the main board. So what are we going to do? Let's do 3 and 4 because it's easy to get to it. First, let's take one that we know is okay. Turn on channel 2. Turn off channel 1. Pull it up to the center. And turn on the scope. And move it. Yeah, and shrink it. There. Maybe over here. That'll probably be good enough. You can see what I'm doing. All right. Turn it back on. Not short anything out. So what are we looking at here in the manual? Channel 4. 1, 2, 3, and 4. So we're looking at U102B. That's U102 right there. B would be pin 7. Yes. So we want to look at pin 7. Okay, we got, what are we on? We're on 1 volt DC. Let's take this to 100. No. What the heck? Oh, there's a DC voltage on it. Anyway, so yeah, that's one thing I really don't like about this little scope is its inability. Well, yeah. Anyway, but that's what we've got there. Okay, and that is on 4, not controlled yet by the thingy, the volume control, and this is 3, and pin 3 is on oh good, 102 pin 1. Same input. Ooh, same input, same output. There it is. All right, so it's good up to that point. Well, let's see. What do we got after that? So we got U15. U115? I think they're over here. Yeah, U115. I need another lengthenizer here. All right. 115. So if we come into this amp here, which also has the level, which is right up here. If I turn this into a hand, can I? Yeah, it's easier to see. Okay, so it's U115. Channel 4 we know is working. That's why I'm doing channel 3 and 4s because they're both in the same IC. I was hoping for that. All right, so we're looking at pin 7 of U115. So there's pin 7. Yeehaw, baby. I think we can cut that down just a little bit. There's a volt, pin 7. And channel 2. Okay, so there's pin 7. And then the other one's going to be pin 1, more than likely. Yeah, pin 1. That's the same. Okay. So our input amp is okay. Our gain amp for our changing our gain. Here, let's try 3. Yeah, it's working fine. Okay. Where does it go from there? Well, let's see. It goes over through C159 or C158. Yeah, 58 because this is 60. So you kind of got to guess. So this is 158. And all combined through this 11K resistor, and it all goes up here to a resistor and Q and U109. Where is, let's see, this is Q113, U109. Let's well, there's U109 right there. And that is right underneath that power supply, so I can't even really get to it. Where is Q13? What did it say? Q113, 114, or the input. Let's just see if there's any input at U11 or U112D, because I can't get to any of this stuff. It's all up underneath this power supply thingy, I think. Yeah, Q109's up under there. Q113. Oh, here's U112 right here. Right here. So I can get to that. So what do I want? And as you can see, U112, which is right here, feeds a FET switch, and it goes to U112C, which goes through this amp to the output to one of your transformers, your transformer output for channels 3 and 4. Okay, so if we go to 112C pin 13, 112, so this is 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 14, 13. What do we got there? We got zip. Why? Because I'm on 4, not 3. No, they're even. They all should be the same thing. Okay, Q123, where are you at? 127, 125, 131, 132. And they're going to put 123. It's over here. I can get to it. Cool. Show you. 123 is right here. So if I can get to Q123, I don't know what the base output of this thing is. Nothing there. Nothing there. And a little bit there. Does that change? Yeah, we're on 1 volt, 200 millivolts, and it does change, but it doesn't go very high. All right, so let's put this in channel 4 because they are all combined at this spot. Channel 4 goes quite a bit higher until it starts to. So that's working, but that's all right. We'll back up a step. 112 pin 8. Yee-haw! Yeah. Okay. So they're cutting it way down there. So take this down to a volt. This is channel 4, turning it up and down. And this is channel 3, turning it up and down. Huh? This is the master. Okay, so it's the same. All right, how about pin 14? There's pin 14 on channel 3. Bad pot, up and down. And that would be on 3. That's on 2 point something or 3. Actually, that was on 4. So let's set both of these at 3. And what have I got? On a 2-volt scale, what does it say I have? 12.5 volts peak to peak. Let's go here. Whoa. 3.25 volts peak to peak. Okay. So it's different there on 14, but on 8, I've got 3.01 on channel 3, and it is different there too. So, but I can't get to 109. I got to get to C142. I can't get to C142. Huh. What the heck? Over? What are all these things here? So, let's just pull the manual up for a minute. Okay. So, what do we got? So, each one of them comes in, goes through a cap, through this light variable resistor package. And what are those things? Where are those things? What is that? That is called a U1056 7 and 8. Oh, maybe it's loading it down. I don't know. And that's around C158 and 159. There's C1. Okay. Okay, there is C158. There's C159, 160, and 161. So, what have we got here? 158. So 158 is going to be channel 4. Let's try channel 4. And the side that is connected to R202. So I want one end of R202. Okay, right there. And I want the other end of R202. Well, the other end R202, which I would expect it to drop. It's 11K. All right, so I got C156, which is pin 7 of that which we already tested, which is fine, U115. So we got that on 11K. Now what about R201? Well, which end? Okay, R201 on that end. R201 on that end. Okay, that's 4.7K. It's a bit of a drop. That's okay. Well, or at least it looks okay. I'm not sure. Let's go over to, which one is it? U1006, I guess. Not that I can read it real well, but it's right here. Right here. And that's this guy. So I got R204. Go out of my way. Thank you. R204. There's one side of 204. It's on 3. Yep. Same as the other one. That looks good. The other side, let's see, R203. Where's that at? Here we go. R203. What? It just drops off to nothing. But as channel 4, which would be a 201, has that and that. So, okay, that's channel 4. On this little guy I got, I think this is right because it goes right to there. Okay, so that's one side of the the resistor in that U105. There's the other side of the resistor, U105. Okay. What about voltages here? Do I have voltages on this thing? Because there's a diode in there that's got to light up that LED. Let's make sure we got voltages. Let's see, your voltage is up there. Yes. Here's one end of it, nothing. Here's the other end of it, 1.8 volts. Okay. And channel 3, nothing. And 0.1 volts. Channel 2, negative 0.2. What the heck is happening? I got 1.6 volts on channel 4. Alright, let's go across this thing and see what we got. Alright, so there's my 1.8 volts across it. 2.1 across it. 2.4 across it. 2.7. So they're all around 2 volts. Alright, let's turn it off. And the resistor. Wonder what it's supposed to be. I don't know. Let's see. Resistance. Alright, what happened to my lead? Here it is. Alright, resistance. Good. Hello? Oh, there we go. Alright, so channel 4. Resistance, because this thing is about 22K when it's turned off. Turn it back on. It shouldn't be. It should be okay to read. $718 ohms after it's been turned on. Okay, so let's take a look at channel 3. We got 23K. Turn it on. We got 20K. It looks like that thing ain't working. Let's try another channel here just for the fun of it. We got 23K off. Turn it on. Now this is saying 20K too. I can't really read that when it's on, I guess. Why? Oh, because there's nothing going into it. I'll betcha. Let's try channel 3 here again. Still reading 22K ohms. Let's try channel 2. I don't know if these things are actuated or turned on, how they're turned on. 1.4K on channel 2. And channel 1. 0.9. 900 ohms. Okay. And we'll just, for the heck of it, do it to channel 3 again. $22K. And channel 4 is... I'm just checking myself here, because I've never seen one of these go bad. 718 ohms. Interesting. So does that change with level? Yeah, it does. A little bit. So I think that thing's bad. That'll be a first. Well, let's see. That means we got to take this apart. And this is not easy. Hang on. I'll be back. Okay, well, I did a little studying of the manual here, and it appears, it's hard to tell because they don't document this real well, and they only document one side of it, the 4 input sides. But it appears that this little board, besides, I think, handling the ability to stack these, I think it also produces a certain amount of feedback for each channel, I believe. But I don't know if anybody out there has the other side of this board. I've got this side, I think. Let's see, on the manual, we go down one to the controller board. Nope, wrong way. Is this? I think this is the controller board. Yeah, this is the controller board. It's got the schematic is all here, and each one of the channels comes up through here on these 4 and goes down through its individual set of clamps, whatever, and equalizers and stuff like that, and through an amp, and it all comes back out of there through up here back down to the board. And I think that is because all this stuff here controls the LEDs and lights them up and that kind of stuff. All this stuff before it, I think it's what it provides some sort of feedback. I'm not real sure about this, but I have, where is it, the layout for the boards. There is the main board. That's the other board. That's the power supply. I have the layout for the control board for that side. That's all I've got, and that's the side. That's the side that faces up. I cannot find a layout for the other side of the board, which is weird. But anyhow, so that's what I think I came up with. So now I'm gonna take this guy apart. Hang in there for a minute. Alright, we're all disconnected. There is a lot of things to take off on these. I think you got to take these guys off from the front and back panels, if I remember correctly. If you don't want to watch this part, go ahead and skip ahead. But if you want to know how to get one of these things apart, continue watching because there's a lot of it. Okay. Now, I think these are, yeah, those are smaller. Number ones, you got to take loose all of the XLR connectors back here. And each one is held in by 2 screws. This is fun. I guess they wanted to make sure it didn't fall apart out in the field. But I think some things are just a tiny bit of overkill. Let's see. This one, I don't think, no, I don't have to take those off. Almost there. Alright, so there's all of those guys. That's still not loose. Oh. There's 3 on the bottom. Little bitty short beveled flatheads. And there's 3 in the front one too. Probably going to have to take those out. Running out of places for different colored things. Well, that's loose. That's cool. All right. Wonder if I have to take all the knobs off too. Here's these three. Probably. Why wouldn't you? Yeah, that is not loose at all. Alright, that click you heard, by the way, when I pulled that one off, this thing has a built-in oscillator, so you can set it up for 0 level or -4 or whatever you want, depending on what your downstream stuff needs. Oh, good, groovy. Guess? Bad guess. Okay, put you guys so as not to lose them over here. Alright. Ooh, okay. There's 1, there's 2, 3, 4, 5, and 6. I love those little wrenches. Those are a 3D print project. Those are metric. But it does save the face of these things. Yep, it's moving. So these are attached to the board. Like I said, they didn't want it to fall apart in the field. Shure has always been pretty well built stuff. Alright, oh, and there's little plastic washers on them. Come on, get off of there. Let's not lose those. Those are thin. And there you go. Alright, so that's off. Good. And there's washers behind it too. From what I've seen in other stuff, you really must preserve these washers, because if you don't, when you go and crank it down on the front, it'll bind up on you and they won't turn. Okay. Alright, we'll get this out of the way right now. We know that these pots are bad. So we're just going to give them a little squirt and let them sit while we're doing this. Okay. I use Dioxit F5 fader. I find that it keeps them oiled up instead of drying them out real bad. Alright, so we need to get rid of the power. Wait a minute, we have to get rid of this too, don't we? Battery compartment, because it's screwed right down through the box. Alright. There. Alright, so the back is loose. That's loose, I guess. Yeah, now I gotta get that off of there. Wow, tight. Okay, alright. So that takes care of that. And that. And it's still fastened down there, just tight as it can be. So let's get rid of this before we break it. That's just a little IC header thingy, and they're pretty fragile. That's good. Put him aside. That's good. Put him aside. There. Now, what is holding you in? Well, I guess we got to take that off now. Guess. Wrong guess. Okay. Yep, that's it. So now we got to take the power supply off. Okay, there's the power supply. 4 little standoffs. I go over there, and it's still solid as solid as a rock. Ooh, I can see under here. These guys. Really? Doesn't appear to be these ones in the front because it moves. Is that it? Yes, that's it. Finally. Wow. That's an impressive number of screws. Alright, so we're saying channel 3 here, huh? Well, let's take this out. I'm going to have to start up the machine. Be right back. You know, while we're here, let's take a look at some of these capacitors and just get an idea. I mean, they're really good caps, so I'm not real worried about it, but let's see what we've got. Can you see that guy? Yeah, I guess. Little guy here. That's a very small capacitor. What about all these little guys on the bottom? Specifically, wow, where are they? Here and here? Here and here, okay. The little guys. 4, 5, 4, 4. Oh, those are good. We're waiting for the solder sucker to heat up. Alright, so there's a whole bunch of them here. 2, 2, 2, 2.6. There's a bunch over here. 2.1, 2.1, 2.1, 2.1. Well, that's good. How about you big guy here? Yes, okay. Wait, oh. What do we got here? We got 0.2. What did it say? Stay on there. Doggone it. 0.1 something. 0.1 something. 0.1 something. Those are okay. 0.3 or 0.2. That's okay. Yep, those are all right. Okay, well, I don't think it's capacitors in here. I didn't think it would be. Alright, so we're hotted up over here. Let's suck a little bit. So which one is it? It's this one. Just got a new tip for my desoldering station. Actually, that's not true. I got a whole new gun piece because I went to tap this one out and slammed it against the side of the desk and broke it. Alright. I'm going to pull out 3 and 4. So as I can compare them. Did I get you loose? Yes. Okay. We'll put 4 over there, because we know it's good. Didn't get you done. Why not? By the way, if you ever buy one of these guys, the tips, the tips will go bad on you and widen out dramatically, and you'll lose all of your suction. Not a good thing. You'll fight with it. You shouldn't have to fight with it. All right, come on, damn it. Okay, got it. There's that one. Now they are marked with a little arrow thingy there, see? All right. So let us take that there and get our meter leads back here. I think we're still on resistance. Yes. Okay. So good one, bad one. This is the resistance end here. Or not. Bring the meter up here. All right. Which one is which? This end is diode. This end is resistance. I do believe. I am not reading anything. Okay, go with a good one. Alright, so the good one is reading in the mega ohms. So we really can't read that one. This one's reading my fingers. Well, I mean, they're supposed to be pretty high up there, and they are. All right, well, can't do that. We got to measure. See if we can measure these. They run around 2 volts, I guess. That's what it said. So let's take the power supply down to 2. Okay. So I got the power supply is about 2.3 with current limited to about 30 mils max. Okay, so we'll clip onto this end of it, which is the resistor end, and we will, I don't know which way these go. Well, we'll figure it out. Okay, so if I go this way, yeah, that's shorting it out. If I go that way, I've still got mega ohms. What the heck is going on? Because that's not drawing any current at all. Oh, there we go. All right, so they take about 40 mils to run. And with the power applied to the diode, I'm getting about 300 ohms. Okay. On this one, open it up, and it's mega ohms. Okay, so that supposedly is the good one. Let's test this one. It is mega ohms. And hook it up to the diode the correct way. It's drawn about 20 some mils. Ah, so either the diode's bad or the resistor inside of it's bad, but it's 22.5K versus 300 ohms. Well, Positive proof that is bad. Okay. So what is this thing? It is a HTV P873A. Well, hold on. Let me see if I can find something here. Okay, well, I found something on eBay for $21.85 each. Wow, okay. Here's one for $20.85. You know what? I think maybe let's go to DigiKey. So what are we looking for? Well, let's try it. Okay, that wasn't easy, but I found something. This is from Advanced Photonics. It's called an opto-isolator photocell optocoupler, one channel. Now, we know this thing's supposed to go down to about 300 ohms when it's turned on, and it draws 20 to 40 somewhere mils of current. So we got this version here, and there's a whole bunch of them. Rising. Okay, the DC forward IF max 25 mils, somewhere around there. 60 volt power supply max. Does not tell me what the on is. So let's go to here, open this up. All right, so we got there's our photocell, blinky blinky. Why you no show what I have here? That would probably be the manual then, wouldn't it? Well, that's interesting. I didn't realize it would even do that. Ah, okay. Here it is. So it is an NSL32SR3. We need to look at its ratings. Let's see, what do we got here? Isolation voltage, don't care. Topper, don't care. Okay. Forward current, 25 mils, approximately max is what it's going to draw. 2.5 milliamps. Your reverse current, 10 microamps, don't really know or care. Peak DC voltage is 60. On resistance, this is what we need. On resistance at 20 mils is 60 ohms max at 150 typical. For on resistance at 50 mils, well, I'd like to see that more around 30. So what are we looking at? On resistance for current 20. Yeah, okay. That's just exactly what the other one said. All right, a little more looking around. Hang on. Okay, I found another version of this. Let's see what this looks like. It's well, make this a little bigger so you can see everything. Wow. There we go. Did that wrong. I'm trying to get this. Hold on. Ah, well. So what does this one say? On resistance, 16 milliamps are on, is about 160 and max of 200. So this one is just the NSL32. CU 40, forward current 40 max, which, remember, that's what we showed when we were doing this. 2.5 volts. That's correct, forward voltage. Peak cell voltage. I like this 200 ohms, and our off resistance 500K. I don't think it's going to make any difference at that level because we saw how badly it dropped it at 20. Okay, I'm going to order them both and let's see what happens. We'll return. Okay, well, it's been a few days and I got some parts in here. And our board back on the bench again. We got the NSL 32SR3 and the NSL 32. And I think we said before, I got two of each. We're going to try this, the straight 32, and see what it looks like. We're going to put it and measure it first. If I can get the bag open. I love the way they say these are. Wow. Well, times have changed in 20 years, I guess. Little difference in size. What does the what does the manual say? Which one is that? I think that's the YouTube. Nope, not the YouTube. It is the manual? Yeah, okay. So, the manual says that the long side is the photocell, the short side is the LED. So, let's put the meter back up again. Okay, there's the meter. When I got it down here, which way draws the milliamps? There we go. And this way, $88 ohms. Okay. Let's check the other version and see what it says. Because that is a little low. I mean, it may not make any difference. I don't know. We'll find out. When in doubt, buy more. Alright. So the diodes are different. And the which way is different here. Yeah. So that way it's drawing current. It says about 70 mils. And our resistance is around 19 ohms. So if I drop this down, very hard to do. There's about 40 ohms. Okay, well, let's try the first one, just because of what the spec sheet said. Yeah, this is getting to be a long video. Alright. So, this thing is, that's black. It's 2. So, that's 1.5. So, it is marked with a little dot for the ground end. And which way is the ground end? Okay, ground end goes to the left. Alright. So I think I'd better look that up on the manual. Oh, where is it? Okay. Yeah. Alright, if we bring up the manual here, you can see that the cathode goes to ground, so that would be correct. Alright. Alright, so fold you over that way. The resistor doesn't really carry in El Shorto position. This goes here carefully, and this goes over here still carefully, but not quite as touchy as that is. You could sit right there, and you can sit over there. Alright, so we got inputs, we got outputs, we got on, we got power, DC power plus, DC power minus. The light came on. That's a good sign. So where did the scope go? The scope shuts down. I hate that. Hold on. BRB. Okay, we're back. I want channel 1. Yes. Power on. Everybody's good. Turn down, 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 down. Everybody's down. Okay. Weehaw. Okay, well, there's channel 4. We can turn this down a little bit. Turn this up. So this is, so the channel 4 is straight up and down. That's straight up and down. That's straight up and down. All right. Let's try channel 3, please. Yes! We have it. Channel 3. Output, it works. Output, it works. Now, let's see. What do we got? We're reading, what, at about 260 millivolts peak to peak. Let's crank that up. Let's make that about 680. And you about 680. They are virtually, well, I don't know. Yeah, this one's just a little hotter than the other one. Not by very much, though. The VU meter in the red is 4 there, and it's 4 there. So there it's 4. There it's 4. So they're equal. It works. It actually works. Fantastic. Well, I guess if you got one of these things and you got a low channel, check these guys. You know, it's not always ICs. This time it was a bad photoresistor diode set. And they are available for $3 a piece. That's better than 20 something. Cool. All right. Well, got that one fixed. You can send it back to him and he'd be happy. So thanks guys for watching, and don't forget I have a Patreon channel, Patreon AERV blog on Patreon. I'm also up on Odyssey, and don't forget to subscribe and ring the bell to make sure you see when I'm doing more of this stuff. And don't forget to comment down there. I mean, I don't get very many comments. I'd love to get more comments. That would be great. So, hey guys, thanks for stopping by. Till next time.